Hi, in this video I'm going to make a reverse engineering for this tile lever. This tile lever usually comes into a pack of 3. This pack costs around $4. It's Arc 2 TL 1.2. So this end we use for removing the tile from the limb. This end we'll be using for removing the tile bead. So there's two parts. I will start by 3D scan this part using Matter Inform 3D scanner, and then I will reverse this in the FreeCAD. After I will reverse it, I will do the finite element analysis, which is one of the functions in the FreeCAD. It could be very useful. You can design for the stiffener and the thickness. When the force is applied to this lever, you can predict and simulate the result in advance. Okay, let's start with the 3D scanning. Matter Inform 3. So just place the lever here to the left a bit, adjust the exposure. Okay, this will be about right. I don't need a color. I use the scan density medium and 6 rotation of the scan. Calibrate turntable. Okay, I'll start the scan. Okay, here's the first scan. So I need to make a second scan to scan the bottom part. I click on Add Scan. This will be second scan. I flip it over. Then I click on Start Scan. So now we have two scans that I will merge them together. I click on Author. First scan as a reference, and second scan to merge into the first scan. Click on Continue. Aligning is complete. I will merge the scan together. Click on here. Click on Visible Only, and then I will mesh it with the medium setting. Okay, meshing is quite fast, less than 10 seconds. Okay, let's add this to the project. Go back, and here's what I'm going to export. Click on here, click on Export as OBJ. Here is in CloudCompare. I will drop in the mesh that I export from Math3. Click on EDL, so I can see it clear. So here's the mesh, but I'm going to reverse this with the FreeCAD, and it's easier to trace with the point cloud because point clouds contain no edges and faces, so you'll be able to see it through like an X-ray frame. So best way to reverse in CAD is by using the point cloud. What I do is I click here and go to Edit, Mesh Sample Points. It's quite a small piece, so I will try 500,000 point, 500,000. So now if I turn off the mesh, right, here's a point cloud. See, one thing to know that point clouds from Math3 is very thin wall, so it will be very precise when you do reverse engineering. The point cloud should be extremely thin like this. See here, there's two scanners that give a very clean and a thin point cloud that I'm using is the Raptor from the Clarity and a Math3. They give a thinnest point cloud. I will align this to the XY plane. Click on here, the level tools. Click on 3 points. 1, 2, and 3. So now it's level to the XY plane. Okay, I want this plane to be on the build plate, so I flip it on the x-axis 180 degrees forward. Alright, so now it's flip, z-axis is up. Align this by rotating along the z-axis. Okay, now it's level. Click on the check mark, and next I'm going to move this into the origin point. Now it's in origin point. Okay, let's move to FreeCAD. I'm going to export this one as a PLY format. Click on Save. Click on ASCII. Okay, now it's done. Okay, here's in the FreeCAD version 1.0. Click on New. I will go to Part Design Interface. Click on Model, and you can start saving it. Thai level YouTube. And next I'm going to create a body, and then I'm going to import the point cloud, the one that we just export from CloudCompare. Click on Open. Okay, point cloud is here. Let me change the color and the point size to 1. Okay, now we have clean point cloud. Let me turn on the origin plane. See, the origin plane is here. Okay, so I will start by creating the body of the lever on the XY plane. And if you see here, the hook part and this side start to rise up from the plane. It's not totally flat. You won't be able to see it, would you? Okay, that doesn't matter. Alright, okay, let's start. I click on the XY plane. I click on the sketch. So I'm making a sketch on the XY plane. Okay, so I will section the wheel. Okay, section the wheel. Okay, next I'm going to trace this profile. Let me turn off the origin. Okay, I use 3-point curve. Start from here to here. So it's curved a bit, not much. This part is straight lined. So I go up to here. And this part is also straight line. I think this part is also straight lined. Yes, it is straight lined. You can lock the line, put a tangent constraint. I'm not going to do that. So this one bend a little bit more. Put some arc here, another arc. Okay, now make sure that the line is all connected. Look at the color of the point. It has to be red color, so that this means it's joined properly. Okay, alright, everything is joined. Let's do this. I put some arc here, then I'm going to trim it. Okay, now we have a connected line. Let's turn off white cloud. You can clearly see it a little bit better. So it's your lever profiles. Close. Turn the point cloud back on. Wheel. Okay, we are on auto wheel. Okay, next I'm going to extrude the profiles. Click on sketch. Click on path. Okay, I'm click on symmetric to plane, so it's in the center. And then I'm gonna change the size to 15. Yep, actually it's a little bit less than 15. 14.5. Yeah, it's 14.5. Now let's try 15. Doesn't matter. I just round it up to 15. Okay, click on OK. Now let's change the transparency to 50%. So now you can see through the point cloud. That's really important. If you use point cloud, you can trace it, because next step we're gonna cut the hook profiles. You see here, the hook is taper, so the profiles of the hook on this face is different from this face. To be able to cut this, you need to create two sketch and doing a loft cut. So I will first create a first sketch on this plane. Click on sketch. So now my sketch is on this plane, and it's better that you need to do some orbit while creating the lines for this sketch. I first create the lines. So I move this line, see here, so that you can see the edge, right? So this line should be here. Next, I'm going to create an arc. Let me lock this line. To create an arc, sometimes it's difficult to see, but you can't. Okay, next I'm going to create a third arc. Okay, the fourth one. Let's go up to about here. Okay, let me lock this and lock this. Let me tangent this to this. Okay, so if you look here, there's some slope angle on this face of the wall, but I want to put this side of the wall to the print bed, so I would just assume that this will be straight line. I'm going to create external geometry on this edge and going to create another arc, go to this point. Okay, and next I'm going to close the profiles. This will be the cutting profiles of the first sketch, so everything in these profiles will be cut. I will remove this projected line. So we have 11 lines in this sketch. So the next sketch that we are going to do a loft cut, it has to contain exactly 11 lines. Let me close it. Let's turn off the pad. Here's the first sketch that we use for cutting. Okay, let me do turn this part on. I create a second sketch on this plane. Click on the plane, click on create sketch. Okay, now let me turn off the pad so it will be easy for me to trace. Next, I'm going to create external geometry. Project all this sketch. Okay, I start with this line. Same old line. Click on lines. You need to do a little bit of orbit to get this right. It looks easy, but it's not easy, isn't it? This tile lever things, I think it's here because it has a round corner. Okay, let me turn on the previous sketch. Okay, next I'm going to create an arc. Let me lock this. We need a second arc. 1, 2, 3. Okay, we need a third arc. 1, 2, and 3. 1, 2, 3. Up. And next it's gonna be end up here. The last one. 1, 2, 3. Okay, we have finished this. Let me trim this. Trim what? Okay, trim it. Can I trim this? Okay, I can trim this. Let me unlock this. Okay, I trace the length of the line from here to here, from here to here, from here to here, and this should be the last one. Okay, let me erase the projected lines. So we have only 10 lines. The last one has 11. Okay, I know it. The first sketch contained construction lines. I have already removed it. So all the lines in the profile is 10 lines. So first and second sketch has the same number of lines. Let's turn the path on. So with this same number of lines, so I can do a loft cutting with the two sketch. I do this by clicking on the two sketch. Click on this subtractive loft. After loft cutting, you still can adjust the position of the curve. It's quite difficult to do because the object is has a round corner, so it's quite difficult to see the exact location. Okay, next I'm going to remove this small triangle. Click on this plane. Click on sketch, external geometry. I'm going to create external geometry. I'm using this line, then I'm going to, okay, I should be able to cut this pocket, close, pocket, reverse. So I cut this one out, click on OK. So we have a small one here. Okay, let me click on this, click on sketch, VF, create external geometry. Okay, I'm going to cut this one out, create a close profiles, close, use a pocket command, reverse, okay. So now we have a clean solid. Let's save it. I will make one more cut here on this lever. I think it's rotated. You see the top of the lever is not level. Doesn't matter. So I will create a plane using a datum plane function. Okay, so I click on 3 points. I will create the plane for making a cut. I click on here. Let's click on OK. Click on the plane. Click on the sketch. So I will create this cut using arc, 3-point arcs, 1, 2, and 3. Move it here a bit, and I'm going to cut this. Close, pocket cutting, reverse, side 8. Okay, now I cut one side. Now let's try symmetric, 12. Right, so I cut symmetric, 12 millimeter. Click on OK. Next, I'm going to can I mirror it? Polar. Okay, mirror. I can mirror the feature and to this plane. Transform body. Get 002 plane. base X, base X, Y. Okay, I can mirror the feature by using XY plane. Let me try. Okay, so you can draw just one half of the sketch, extrude cut, and then mirror the feature. So that's nice. Okay, so they have a contour cut here for gripping with the thumb. So let me try. Which plane is that? Yeah, I think I can draw it on the YZ plane. Cut it. Don't need to create a plane. YZ plane. Click on sketch VF. Okay, I'm going to draw an arc to cut this. Close. Alright, and then I'm going to cut this using a pocket command. I'm gonna cut it to like 15, deep cut, reverse, symmetry, okay, 20, okay, now I cut one half, click on OK. Next I'm going to mirror this pocket command using this, and I'm going to use the XY plane, click on OK. Alright, now I'm getting used to FreeCAD. This is I think my 7th project in this channel. So you probably need support for this, but I don't mind. Let's turn off the point clouds. Save this one. Click on File. Click on Export. So I'm gonna export this one as the STL files. Okay, let me drop these files into the slicer. So this one is flat. Okay, let me try with the support. 3 support. I'm printing this with ABS because that's what I have. I want to change the filament. 90. Let's do this in the X. Let me move this to here. Slice the plate. So we have some support. And let me print this with 100% infill. With 15% infill, it's gonna take 10 minutes. What about 100%? Let's slice it. It's gonna take 20 minutes. So it's twice the time. I need 11 grams of the filament. Okay, I think I will do this. Printing with the infill. Infill, the function is to carry a shear load in the member. So there are 3 kind of loads in the member: axles, shear, and bending. Axle and bending was carried out by the wall, but the shear is carried by the infill. So if you have more infill, it's gonna give you better resistance to shear. Okay, alright, let's send it to the printer. Okay, FreeCAD has a feature called FEM, Finite Element Method. This will allow you to find out when force is applied to your design part, when is it going to break, how much it will deform. So you can predict and simulate with this function so that you can design proper stiffener and the thickness and also the shape of your object to sustain a certain load. In my work, I use a finite element analysis for making a calculation report, and I recommend that if you are not knowing enough about this simulation, you shouldn't use it for safety related tasks. I mean, you can use it for simulation for the 3D print part, some other thing that is not related to safety. Okay, here's our final part. Switch to FEM user interface. Click on this icon here, analysis. Click on the analysis icon, and then you need to apply the materials to your part. Click on this icon and click on this drop down arrow. Scroll down until you see the ABS generate. When you click that, it's gonna show the properties here. Just leave the bottom part blank because you have only one part, so it will apply this material to this part, and then you click on OK. Now you have the material applied to the part. Next, I'm going to create a constraint. Doing the physics simulation, you need materials, and then you need a constraint. To add a constraint, I click on this bond, fix boundary condition, and then I'm going to click on add I'm gonna select this edge here. This edge is going into the tire. When you remove with this lever, it's going into the inner tube, this part. Click it here, and this part will be resting on the rim. So I'm gonna click it here. I click on the edge because I want it to be able to rotate freely on its axis, right? Next, I'm going to click on OK. So now we have materials and fixing point, constraint. Next, I'm going to apply the force. I'm going to apply the force at the end of this lever. I'm going to click on this icon, force load. Click on add, click on this line. See, the force is in this direction, which is wrong. I want it to go down. So I click on this flat plane. Okay, click on the flat plane and then click on the direction. Next, I'm going to reverse direction of the force, and I'm going to use 6 kilograms because I know when I remove the tire, I use about 6 kilograms of force to pop up the tire out of the rim. So I'm going to put 60 Newton for the force. Click on OK. Now we have constraint, we have force, we have materials, almost everything that you are going to need to mesh this model. Click on the final part, the part that you just made. They have two modes, N and G. Let's do the G because the N doesn't work. Let's click on apply. Slice work. So I'm gonna click on OK, and then I'm gonna click on the S. Let's turn out the final part. The G mesh look better than the N mesh. Let's try if it work. Click on solver. Click on here. Okay, it's work. So if the N doesn't work, try the G. So now you have the result. Let me turn off the pipeline CCX. Now you see your mesh, your fixing point, and the force. I will double click on CCX result. With this, click on this placement, click on show, this check mark here, and then you can simulate the movement of the lever. See here? So when you simulate the movement, you know which part requires stiffener, which part require a thicker dimension. Okay. Close this one. That one we'll be using for simulation. We come to the pipeline CCX result. This one we plot the stress of the material. If you click on here and then click on 1 misses stress. Okay, now you have your stress contour plot on the surface of your design. Because ABS will break at 30 megapascal. So anything above 30 will be break. If you look at this diagram on the right, you have 2.879 exponential plus 0.7. That means it's 28 megapascal. So this one is very close for a breaking point. This color, the green color. So anything that is in the green color will break when you apply 6 kilograms of load. So it will start to tear from the surface here. So in this design, you don't need 100% infill because the stress from the bending will only appear on the skin of your model. So if you put 15% infill or 100% infill, you're gonna get the same result. So the outer part of the model, which is the skin, will start to break, and it will start to break here first. This yellow, that's 43 megapascal. Some ABS can resist up to 60 megapascal. The original part, they are injected mold, so I think it can resist up to 60 megapascal, so it won't break. So, but this one will, right? So you know in advance which part will break and where it will break. Next, I'm going to plot the displacement. This is where it will move. So the tip of the lever will move 13 millimeter. The unit here is in meter, so 0.013 is 13 millimeter. So it's moved. You have to consider yourself as a designer. Is that 13 will be too much? Okay, let's make another simulation. Okay, I'll make a second simulation with the same part. Let me turn this off and turn on our part. Next, I'm gonna create a new simulation. Analysis 001. Click on materials, click on the ABS, click on OK. Okay, now the material apply to the part. Next, I'm going to create a fixing point because I'm going to simulate this hook. This hook will be used for removing the tie bit, because I want to know if this hook will break when removing the tie bit, which is require the same amount of force, about 6 kilograms. Click on here, click on add. So I'm gonna put the fixing point on the vertex 1, 2. Let's try it 3 and 4. So I'm gonna fix this 4 point. Click on OK, and I'm gonna put some force. Force add. You can put the force on the surface. Let's reverse it. 6 kilograms, 60 Newton. Click on OK. Now we have a fixing point force. Let's mesh it. We use G mesh, right? Click on apply. Click on OK. Okay, now we have the mesh. We have fixing point. We have force. Next, I'm going to click on S, okay, for the solver, and then let's run the simulation. Okay, I have finished the simulation. We do the same thing. Move to CCX result. Let's simulate how the hook is moved. This is how it's moved when it's being when the force is applied to the hook. See here, so you know where you need to thicken the materials. Right. Okay. Next, I'm going to go to post pipeline result. Click here. See post pipeline results up here. Next, you are going to click on here. Click on one Mrs. stress. Now you see your stress. The lead one is 72 megapascal, 7.256 exponential plus 7. So it's a 72 megapascal. It's closer to the part where you hold your hands. So when you remove the tie bit, your fingers will be here. So it will be the support. Anything above this light green color will break. So this part will break if you apply 6 kilograms of force. All right. Okay. So you can estimate. You can estimate and predict the behavior of your design when it's gonna break. Is it strong enough, or save some materials with the proper thickness. Okay. Yeah, let's take a look at the 3D printing result. This is 100% in fill. 20 minutes of printing in ABS. This part is quite support, so it doesn't look very nice. Let's compare this to the original part. Okay, I have this scale. I'll try to pull this hook into this direction for 6 kilograms. Okay, I put like this, right? 1, 2, 3, 4. So it's baked at around 4 kilograms. So our calculation is correct. It won't be able to hold 6 kilograms of force. So I probably need to put this on a real tire. Let's check. Okay, first, let me deflate the tire. Okay, here's our tools. Okay, it's the moment of the truth. The force that I use is much less than 6 kilograms. Probably around 2 kilograms. So you can use this for, I can hear a crack sound, but it works.